Pluto is a small planet shrouded in mystery due to its distance from Earth. This makes it a great target to be observed by the James Webb Space Telescope. Located just beyond the orbit of Neptune in the Kuiper Belt, astronomers have long speculated about the composition of the planet. Now, thanks to the JWST, a new frightening discovery has been made that has left astronomers searching for answers. Let's take a closer look. Pluto is the largest known dwarf planet in the solar system and used to be considered the ninth and most distant planet from the Sun. The strange world is located in the Kuiper Belt, a zone beyond the orbit of Neptune, brimming with hundreds of thousands of rocky, icy bodies, each larger than 62 miles across, as well as 1 trillion or more comets. Pluto stopped being a planet in 2006 when it was reclassified as a dwarf planet, a demotion that attracted controversy and stirred debate in the scientific community and among the general public. American astronomer Percival Lowell first suggested that Pluto existed in 1905 when he observed strange deviations in the orbits of Neptune and Uranus. Lowell thought there must be another whose gravity is tugging on these ice giants, causing discrepancies in their orbits. Lowell proceeded to predict the mystery planet's location in 1915, but died 15 years before its discovery. Pluto was eventually discovered in 1930 by Clyde Tombaugh at the Lowell Observatory, based on predictions by Lowell and other astronomers. Pluto got its name from 11-year-old Venetia Burney of Oxford, England, who suggested to her grandfather that the New World get its name from the Roman god of the underworld. Her grandfather then passed the name on to Lowell Observatory. The name also honors Percival Lowell, whose initials are the first 2 letters of Pluto. Since Pluto is so far from Earth, little was known about the dwarf planet's size or surface conditions until 2015, when NASA's New Horizons space probe made a close flyby. New Horizons showed that Pluto has a diameter of 1,473 miles, less than 1/5 the diameter of Earth, and only about 2/3 as wide as Earth's moon. Observations of Pluto's surface by the New Horizons spacecraft revealed a variety of surface features, including mountains that reach as high as 11,000 feet, comparable to the Rocky Mountains on Earth. While methane and nitrogen ice covers much of the surface of the planet, these materials are not strong enough to support such enormous peaks, so scientists suspect that the mountains are formed on a bedrock of water ice. Pluto's surface is also covered in an abundance of methane ice, but New Horizons scientists have observed significant differences in the way the ice reflects light across the dwarf planet's surface. The dwarf planet also possesses ice-rich terrain that appears to look like a snakeskin. Astronomers spotted similar features to Earth's penitence or erosion-formed features on mountainous terrain. The Pluto features are much larger. They are estimated at 1,650 feet tall, while the Earth features are only a few meters in size. Another distinct feature on Pluto's surface is a large heart-shaped region known unofficially as Tombaugh Regio. The left side of the region is covered in carbon monoxide ice. Other variations in the composition of surface materials have been identified within the heart of Pluto. In the center left of Tombaugh Regio is a very smooth region, unofficially known by the New Horizons team as Sputnik Planum, after Earth's first artificial satellite, Sputnik. This region of the planet's surface lacks craters caused by meteorite impacts, suggesting that the area is, on a geologic timescale, very young, no more than 100 million years old. It's possible that this region is still being shaped and changed by geologic processes. These icy plains also display dark streaks that are a few miles long and aligned in the same direction. The lines may be created by harsh winds blowing across the dwarf planet's surface. NASA's Hubble Space Telescope has also revealed evidence that Pluto's crust could contain complex organic molecules. The planet's surface is one of the coldest places in the solar system. Temperatures here can drop to around -375 to -400 degrees Fahrenheit. When compared with past images, pictures of Pluto taken by the Hubble Space Telescope revealed that the dwarf planet had grown redder over time, apparently due to seasonal changes. Pluto may have a subsurface ocean, although the evidence is still out on that finding. If the subsurface ocean existed, it could have greatly affected the planet's history. For example, scientists found that the zone of Sputnik Planitia redirected Pluto's orientation due to the amount of ice in the area, which was so heavy it affected Pluto overall. New Horizons estimated the ice is roughly 6 miles. A subsurface ocean is the best explanation for the evidence, although looking at less likely scenarios, a thicker ice layer or movements in the rock may be responsible for the movement. If Pluto did have a liquid ocean and enough energy, some scientists think it could harbor life. The planet's highly elliptical orbit can take it more than 49 times as far out from the Sun as Earth. Since the dwarf planet's orbit is so eccentric, or far from circular, Pluto's distance from the Sun can vary considerably. The dwarf planet gets closer to the Sun than Neptune is for 20 years out of Pluto's 248 Earth years long orbit, providing astronomers a rare chance to study the small, cold, distant world. As a result of that orbit, after 20 years as the 8th planet, in 1999 Pluto crossed Neptune's orbit to become the farthest planet from the Sun. When Pluto is closer to the Sun, its surface ice thaws and temporarily forms a thin atmosphere, consisting mostly of nitrogen, with some methane. Pluto's low gravity, which is a little more than 1/20th that of Earth's, causes this atmosphere to extend much higher in altitude than Earth's. When traveling farther away from the Sun, most of Pluto's atmosphere is thought to freeze and all but disappear. Still, in the time that it does have an atmosphere, the planet can experience strong winds. The atmosphere also has brightness variations that could be explained by gravity waves or air flowing over mountains. While Pluto's atmosphere is too thin to allow liquids to flow today, they may have streamed along the surface in the ancient past. New Horizons imaged a frozen lake in Tombaugh Regio that appeared to have ancient channels nearby. At some point in the ancient past, the planet could have had an atmosphere roughly 40 times thicker than on Mars. Pluto has 5 moons in total, the largest and most unique among them being Charon. Charon is so big that with Pluto, the pair is considered a binary planet system. When NASA's New Horizons space probe made its historical flyby of the system in 2015, it captured a wealth of data about the amazing moon. The moon orbits its planet every 6.4 Earth days, the same amount of time it takes Pluto to rotate once. The two are tidally locked, with one face permanently turned toward the other. The pair likely formed at the same time when two objects collided. Unlike most of the planets and moons orbiting the Sun, the Pluto-Charon moon system is tipped on its side, and Pluto has a retrograde orbit compared to other worlds, both suggestive of a violent beginning. The Proto-Pluto and Proto-Charon were likely quite different, leading to 2 different types of worlds. The remaining debris likely formed the other 4 smaller moons of Pluto. The south pole of Charon entered polar night in 1989 and will not see sunlight again until 2107. New Horizons was able to study some of the nighttime landscape as it was very slightly illuminated by light from Pluto. The moonlight of Charon also helped scientists to study Pluto once the spacecraft left the daytime side. They gazed back on the dwarf planet in the reflected moonlight of Charon, gathering even more information about the world with the help of its companion. New Horizons revealed an unusual feature, a surprising red formation at Charon's northern pole. This reddish hue comes from Pluto's atmosphere. Pluto itself is too small to hold onto its atmosphere for its lifetime, so the nitrogen, methane, and carbon monoxide leave the surface. Close orbiting Charon captures some of the material, which is then funneled toward the surface. As the material collects, galactic cosmic rays and ultraviolet light from the Sun interact to create tholins, complex compounds that form through the irradiation of simple organic compounds. While Pluto can hold onto a tenuous atmosphere, Charon is not large enough. The Moon is extremely cold, with polar temperatures ranging from -433 to -351 degrees Fahrenheit. According to researchers, the gas that reaches Charon likely freezes directly into the surface, skipping over the liquid phase. The remainder of the surface of the large moon is made up of water ice. Charon is more heavily cratered than Pluto, suggesting that the surface is older than its companion. Charon also boasts a spectacular canyon that stretches more than 1,000 miles across the surface. The chasm is at least 4 times longer than Arizona's Grand Canyon and twice as deep in some places. The enormous slice likely wraps around the unseen dark side of the moon. To the south of the enormous canyon lies a smoother plain informally known as Vulcan Planum. The surface here is less cratered than in the northern region. Grooves and faint ridges on the plain suggest wide-scale resurfacing that may come from a cold volcanic activity known as cryovolcanism. Since its launch in December 2021, the JWST has sent back dazzling photos of distant exoplanets, intricate nebula nurseries, and galaxies whose light has taken over 13 billion years to reach our eyes. Now it has set its sights on the Kuiper Belt, a massive disk just beyond Neptune's orbit that's home to comets, asteroids, and other icy bodies. The worlds and objects beyond Neptune are largely unexplored territory, Pluto included. But work has begun on using JWST to uncover them. As the observatory continues its mission of exploring the universe with greater depth and sensitivity than any telescope, it will be able to see Kuiper Belt objects in an entirely new light. For planetary scientists, the JWST's greatest strength is its incredible spatial resolution combined with its ability to capture images using infrared spectroscopy. JWST's cameras will be able to use sunlight reflected by objects in the Kuiper Belt to study the absorption and emission lines that show which atoms, molecules, ices, and minerals are giving off light that vibrates in its atmosphere. Away from Earth's atmosphere, which blocks infrared light, the JWST Near-Infrared Spectrograph Integral Field Unit will reveal these objects' light from the near-infrared to the beginning of the far-infrared. While the telescope is still collecting data from the dwarf planet and its moon, it has already made an important discovery. It has been observed that Charon is bluer than Pluto, which means that both worlds have different surface compositions and structures. Further observations on Pluto suggest it has a smoothly reflecting surface layer. A detailed analysis of the image also suggests there is a bright area parallel to the equator on Pluto. This discovery is significant as it may prove Pluto and Charon formed at different times. If you found this video informative, you may also like this one, which talks about a black hole that may be seen from Earth in 2022. Do you think Pluto should be classified as a planet? Please share your thoughts in the comments section below.